Hey guys, welcome to day 7 of at home learning. I hope you are finding yourself well today. Miss seeing you guys. I'm hoping maybe some of you will reach out and just say hello, but whatever. I'll just sit here by myself too. That's cool. Um, Today we get to start chapter 4. You might be asking yourself, shouldn't we have an end of chapter 3 test? And the answer is yes, we should, but I feel with the distance and that we had spring break, I don't want to mess with that. So we're just going to move on to chapter 4 today, and we'll cut our losses there. So no big test for you. Hopefully you're not too bummed about that. Chapter 4, however, is all about inequalities, and it's going to be not too bad of a chapter. You should enjoy this because it's just a lot of solving of algebra problems. It's a pure algebra chapter, lots of just solving inequalities, which are really kind of equations. In case you don't know, an inequality is instead of having an equal sign, it's going to have a less than sign, a greater than sign, or the less than or equal to and greater than or equal to signs. So we've seen a little bit of this, especially when we talked about domain and range in the last section. So because it's an inequality, that means there are an infinite number of solutions because, if your answer comes out to be x is less than 2, well, that means that anything that's less than 2 would work. So, 1 would work, 0 would work, negative 1 billion would work. Any number, as long as it's less than 2, will work. So what you do is you have your algebraic solution, and then you also typically represent it on a number line because it's just a nice visual aid to kind of think about your solutions. So you should remember that if we have a problem with a greater than symbol or a less than symbol, we're going to use an open circle because that value is not included. And then if we're going to use one of these symbols in our problem, we're going to have a closed circle because that means that value is included. So first off, we're just going to practice. Say you did a problem and you got your answer to be x is greater than or equal to negative 1. So you're supposed to graph this on a number line. I don't make the number lines too hard. All I do is I just make a line, and whatever value I get, I put that in the middle of my graph, and then I'll just put one value to the right and to the left of that number. And because this is a greater than or equal to, remember that's going to be a closed circle, so we're just going to put a nice big filled in circle on negative 1. And what are the values that are greater than negative 1? Well, that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way that way. So this is the way that we shade. So once we get a solution, we'll put a dot and we will shade in that direction. Let's look at number 2 together as well. If you get an answer that says x is less than 5, so again, you're just going to draw a line. You'd put 5 in the middle, you'd put 6 to the right, 4 to the left. That would be an open circle because there is no line underneath. And what are the values that are less than 5? Well, 4, 3, 2, 1, and so on are less than 5, so you would shade that direction. Now here's another nice thing. As long as your variable is on the left side of your inequality, if you look at that and think of it as a arrowhead, which way is it pointing, right? If you put the line there, which way is it pointing? It's pointing to the right. Which direction did we shade? We shaded to the right. If you look at this one, you draw the line and it makes an arrow. Which direction is it pointing? It's pointing to the left. We shaded to the left. So that's one thing you can do. As long as the variable is on the left and the number is on the right, it's going to point the direction that you're going to shade, which is kind of nice. Okay, so what we're going to do is we're going to be given problems like this, and we're going to solve them like we did equations. There's only one difference when solving inequalities, and I put it in bold here. The direction of the inequality sign must be reversed if you multiply or divide the inequality by a negative number. So we'll see that situation down on 3 and 4, and I'll show it to you there. So let's look. These are nice and easy to solve. If x plus 4 is less than or equal to negative 6, you might draw the line. We haven't really been doing that lately. So how would you get x by itself? Well, you would subtract 4 from one side of the equation. If you subtract 4 from the left side, you have to subtract 4 from the right side of the inequality. Those 4's cancel. I'm left with x is less than or equal to negative 6 minus 4 more is negative 10. We're asked to solve and graph, so we'll quickly put that on a number line. Negative 10 goes in the middle, negative 9, and negative 11. It's a closed circle on negative 10, and it's pointing to the left. The values that are less than negative 10 are to the left of negative 10. Nice and easy. Again, solve this one by subtracting 11 from both sides of the inequality. X is greater than 6 minus 11 is negative 5. So we'd put negative 5 in the middle, negative 4 would be to the right, negative 6 would be to the left. Be an open circle on negative 5 and shaded to the right. Those are the values that are bigger than negative 5. Now notice, we subtracted each time. We did not multiply or divide by a negative number, so we do not flip our inequality. Let's look at 3 and 4 though. How do I get x by itself? How do I get rid of that negative 2? I divide by negative 2. If I divide by negative 2, I have to flip my inequality. So it's no longer going to be greater than or equal to. It's now going to be less than or equal to. So that's the only thing you have to remember. If you multiply or divide by a negative number to both sides of the inequality, you're going to have to flip the inequality symbol. And then the math over here, a negative divided by a negative is a positive. 4 divided by 2 is 2. So it's solved. Now we just have to put it on a number line real quick, get that visual representation. 2 would go in the middle, 3 and 1 to the sides. That would be a closed circle, and we would shade to the left. And then 4, again, how do I get x by itself? You would divide by negative 5 because that negative 5 is multiplying. The opposite is to divide. Divide the right side by negative 5. So if I divide by a negative number, I have to flip my inequality. And 2 negatives again make a positive. 15 divided by 5 is 3. 3 would go in the middle, 4 and 2 to the either side. This is an open circle, shaded to the right. Let's bump it up just a little bit. Oh, not yet, just kidding. Okay, how do I get x by itself? I got to get rid of that 2. How do I get rid of that 2? By dividing by 2. Those 2's cancel. Now, am I dividing by a negative number here? No, I am dividing by a positive number. A negative number is being divided, but we're not dividing by a negative number. So this time, the inequality would stay the same. So only if the number that's doing the dividing is negative do you flip your inequality. So this would be my solution. I would put my numbers on my number line. That's an open circle shaded to the left. 6, again, I'm dividing by positive 3. So I'm dividing a negative number by a positive number. So the positive number is doing the dividing. So I do not flip the inequality. Fill out your number line. This time it's a closed circle shaded to the right. Okay, so we talked about how to solve equations in chapter 2. You can follow those same steps in this chapter. Remember, if there's fractions, you would multiply by the common denominator to get rid of them. And you'd remove parentheses next by distributing. Then combine like terms, move all variables to the left, all normal numbers to the right. And then you get the variable alone by dividing. So those steps are still going to be the steps we follow when solving this equation. Remember, that's kind of reverse order of operations, SADMEP instead of PEMDAS, right? Okay, so let's look. You should be fairly comfortable with solving these. How do you get x by itself? Well, first you move the things that are adding and subtracting, so you got to get rid of that plus 7 by subtracting 7. Now I am not multiplying or dividing, so my symbol would not change. I've got the negative 4x on the left. Negative 9 minus 7 more is negative 16. Now to get x by itself, I got to get rid of that negative 4. To get rid of that negative 4, I divide by negative 4. Here, I am dividing by a negative number. So since I'm done dividing by a negative number, my inequality symbol flips, and do the math, and you should get positive 4. Put that on a number line real quick. 4 would be in the middle, 5 and 3 on either side. That would be an open circle on 4, and you would shade it to the left. Number 8, again, we want to get x by itself, so we're going to move the normal number first. That would be subtracting 45. Negative 7x is less than or equal to negative 49. Again, to get that x by itself, we would divide by that negative 7. I am, once again, dividing by a negative number, so my inequality symbol is going to flip around. It's now going to be greater than or equal to. 2 negatives make a positive. 49 divided by 7 is 7. Make a real quick number line. It would be a closed circle, and you would shade to the right. On number 9, now we have variables on both sides of the inequality. Remember, I recommend to move the smaller one. This x doesn't have a number in front of it, so maybe put the understood 1 in front of it. Which is smaller, 2x or 1x? Well, 1x is smaller. How do I get rid of that 1x? I would subtract 1x from both sides of the equation. 2x minus 1x is 1x, or just x, which is much better to rewrite the rest. Plus 7, less than or equal to, negative 11. Now there's only one more step to get x by itself. We would subtract 7. That's the opposite of adding 7. And it looks like x is less than or equal to negative 18. And just quickly jot that down on a number line to visually represent it. This would be a closed circle once again, and you would shade to the left. On number 10, looks like we're adding parentheses. So the first thing you're going to do is get rid of those parentheses by distributing. So that's going to give us 2x minus 6 on the right side. Going to rewrite that negative 5x and plus 7. Okay. Now it's like number 9. I've got variables on both sides of the inequality. Which one is smaller, negative 5x or positive 2x? Negative 5x is smaller, so I would add 5x to both sides of the inequality. Those on the left would cancel, leaving me with the 7 is less than 2x plus 5x is 7x minus 6. Okay, I like my variable to be on the left side, so I'm going to rewrite it as 7x minus 6 over here, the 7 on the right side. Now, here's what you have to think about when doing that. Notice the pointy side of the inequality is facing the 7. The open side of the inequality is facing the 7x minus 6. It has to stay in that relation. So it's going to really flip that inequality around because the pointy side needs to face the 7 and the open side needs to face the 7x minus 6. So if you flip it around like I like to do, you got to flip that inequality with it. It's kind of like a mirror. And then you go about continue solving that like you normally would. Next, you would get that 6 to the other side of the equation by adding. And looks like we would have 7x equals, or not equals, is greater than 13. Let me rewrite that up here. I ran out of room. 7x is greater than 13. How do you get x by itself? By dividing by 7. And 7 doesn't go into 13 evenly, so we're just going to leave it as 13 over 7. Now, how do you put that on a number line? Well, in this case, I would just put 13 over 7 in the middle of the number line. I wouldn't worry about numbers to the left or right of it. And I would just put an open circle and shade to the right. So that's how you do it if you get a weird answer like that. 11 and 12, bump it up a little bit more, just a few more terms involved. Doesn't make it much more difficult though. Again, I see those parentheses, so the first thing we're going to do is distribute. So I'll distribute that 2. We'll have 2x minus 6. I've got the minus 5 still. Got the greater than or equal to. Distribute the 3. We'd have 3x plus 6 minus 18. Okay, so we've distributed. Next, you're going to look, and are there like terms on the left side of the equation that we can combine? And yes, we can put the negative 6 and negative 5 together to give us 2x minus 11 greater than or equal to. On the right side, we also have those two like terms that can go together. So the 3x gets rewritten. 6 minus 18 is negative 12. Okay, so I've got variables on both sides of my inequality. I like to move the one that's smaller. 2x is smaller than 3x, so I would get rid of that 2x by subtracting. 3x minus 2x is 1x, also known as just x. I've got the minus 12, I've got the negative 11, I've got the greater than or equal to symbol. Much like the last problem, I like my variable to be on the left side, so I'm going to flip it around and say x minus 12 there, negative 11 on that side. The pointy side needs to face the x minus 12, so the inequality is going to flip around like that. One more thing to get x by itself, we just have to add that 12 in to both sides of the equation, and it looks like x is less than or equal to 12 minus 11, 1. Put that on a number line, I'll put it to the side over here. 1 goes in the middle, 2 and 0. I should have a closed circle on 1 because there's a line underneath, and it should be shaded to the left since my x is on the left side and my number's on the right side. Remember, if you solve it and your x is on the opposite side, it's going to make it harder to shade that graph. So make sure your final answer has your x on the left side. All right, number 12, the biggest and baddest of them all. We got fractions, we got parentheses, we've got all sorts of things. So remember, if you have fractions, the first thing you're going to do is multiply by the common denominator. So you got to figure out what's the common denominator between all of those fractions. So let's look. Between 5 and 3, it would be 15, right? So between 15 and 10, let's see, what's 15 times 2? 15 times 2 is 30. Does 10 go into 30? Yes, it does. So 30 is going to be the common denominator. Do you remember how to multiply a fraction and a whole number? Remember, you divide by the denominator, multiply what's left to the numerator. If you need to write that down, we can. We'll put it right up here. Divide by denominator. Multiply what's left to the numerator. Okay. And then also remember, things in parentheses are safe. So if it's in the parentheses, you don't do it twice. So we're going to do 30 divided by 5, which is 6. 6 times 3 is 18. So it's going to be 18 times x minus 4. This is not in a parentheses, so it is not safe. 30 times 5 is the same as 3 times 5, just with a 0 at the end. 3 times 5 is 15, so that's going to be 150. Got my less than symbol. 30 divided by 3 is 10. 10 times 5 is 50. Things in the parentheses are safe, so it just gets rewritten. 30 divided by 10 is 3. 3 times 11 is 33. So we've gotten rid of those fractions. Now we just have a couple of things to distribute. We'll distribute that 18 through first. That's going to be 18x, and then 18 times 4 is 72. And I got the minus 150 still, got the less than symbol. Now we got to distribute the 50. That's going to be 50x minus 50, and then minus 33 more. Okay, looking at that, looks like I've got some like terms that I can put together. On the left side, I can put those two together. That would be the 18x still. And then negative 72 minus 150 more is negative 222. I've got my less than symbol. Those can go together on the right side, so I'll rewrite the 50x. Negative 50 minus 33 more is negative 83. Okay, I've got x's on both sides of the equation. I would move the smaller one, which is smaller, 18x or 50x. 18x is smaller. You get rid of it by subtracting 18x. So I would have negative 222 is less than 50 minus 18 is 32, and then minus 83. Don't forget that x. Again, I like my variable to be on the left side of the inequality, so I'm going to rewrite it as 32x minus 83 is greater than negative 222. Notice that pointy side is still facing the 222. All right, we're almost there. We would add 83 next. looks like we have 32x is greater than, let's see, what's negative 222 plus 83? It is negative 139. And then next we're going to divide by 32 to both sides of the inequality. Sorry, I kind of ran out of room there, but hopefully you can see that. And then we just got to check. I don't think it goes into it evenly. Does it reduce? I'll pull up my calculator for that one. Negative 139 divided by 32. It's not even. As a fraction, yeah, it doesn't reduce. So that's going to be our answer. I'll write it a little clearly over here. X is still greater than, I did not divide by a negative number. X is greater than negative 139 over 32. So we've got it solved. We just have to put it on a number line. Again, we got a weird answer, so we're just going to put our answer in the middle. Don't worry about numbers to the left and right. It would be an open circle shaded to the right. So if you have any questions while you're working on your assignment on my math lab, let me know and I'll help you out. Otherwise, good luck. Somebody just video chat me and say hello.